Good morning, all. Today's resource person is Dr. R. Devi Priya ma'am from Konga Engineering College. Ma'am, shall we start, ma'am?
Yes, ma'am.
Ponni ma'am will introduce Dr. R. Devi Priya ma'am. Ponni?
Yes, ma'am. A very good morning to one and all present over here. Welcome to AICT sponsored Sttp on Internet of Things with Blockchain Application and Challenges Series 1 Day 6. I feel extremely honored to introduce our resource person, Dr. R. Devi Priya, Associate Professor, Kungu Engineering College, Erode. She completed her graduation in BE at Kongo Engineering College, Erode in 2004, followed by his master's in CSC at Kongo Engineering College 2006 with the university rank. She then completed her doctorate at Anna University, Chennai 2013. She initially started her career in industry at Tata Consultancy Service in 2006, serving for 2 years. She then joined as a full-time professor at Kongo Engineering College from 2008 till date. She has published several papers on various journals and also worked under several consultancy projects. She received a CTS Best Faculty Award for her excellent performance in academic and research activities. It is a great privilege to have such a magnificent personality with us today. We feel honored by your presence, ma'am. On behalf of BCET and Department of Computer Science Engineering, we once again welcome you, ma'am. Now let us invite our resource person, Dr. R. Devi Priya, ma'am, to take over the session.
Thank you, ma'am.
Thank you, ma'am.
Good morning, all.
Good morning, ma'am.
I hope in this climate it's a good thing to start with. Shall we start the session? I hope for these 4 to 5 days you would have gained basic insights about what is blockchain, how to use those blockchain. So now we'll see how to integrate blockchain with IoT, right? Is the slide so visible, ma'am? Ma'am, is the slide so visible?
Yes, ma'am. Yes, ma'am. It's visible, ma'am.
Okay. We shall start the session. Okay, I think you would have learned about what is blockchain. So what are the different types of blockchain? So what are the benefits of blockchain? And in yesterday's session, I think you would have learned about Ethereum, how to do blockchain programming in Ethereum, right? So now we are going to see how blockchain can be integrated with Internet of Things. Now both these areas are highly emerging, and it's no doubt that after 5 to 10 years, these two technologies will rule the entire IT world. So again, it is BIoT. Shortly, we call it as BIoT. It's nothing but we connect blockchain with Internet of Things. And I just want to ask you, tell you, is it an evolution or revolution? When we are combining blockchain with IoT, we can say sometimes it's an evolution. Because from the initial days we had the internet concept. So before internet, there was nothing. So people use some other modes for communicating between them. But after the internet world came, and in the internet again there are many advances, and now we are in the world of internet of things, right? So there are many technologies which have evolved, your data science, big data, so all those things, AI, machine learning. And now for the last 10 to 15 years, blockchain is gaining more popularity, and this is an evolution where this blockchain is being integrated with IoT, and it's going to create a revolution in our future world. Definitely, blockchain and IoT will be governing all our activities in our future business or anything that we do in our system. And before going into blockchain you would have gained basic knowledge, but I'll just introduce the basic concepts of IoT for those who are new to this concept. So initially, we were connecting with PCs. We were connecting PCs using www, World Wide Web. So, and after that, we had the concept of mobile or cloud computing, where we can store data in cloud, and from the cloud, people can access their data. So that means cloud is used as a middleware or means to connect different people. And after that, Internet of Things came, and it connects everything. It connects people, your hardware devices, your software, everything. It connects everything, right? So this is the internet evolution, and the next wave is going to be definitely BIoT, blockchain plus Internet of Things. We are at this point, and we are in the process of evolution or creating an evolution to move to BIoT. And Internet of Things, just a basic definition, it's a dynamic global network infrastructure with self-configuring capabilities. It's a dynamic, so each and every word of this definition has some meaning. It's a dynamic global network. Global network means it connects throughout the world. It connects devices, or it can be used to connect. Even though sometimes we connect only our local devices, but we connect the network globally, and it's dynamic. Our data come at any point of time. It can be changed, it can be removed, it can be updated, some data will be inserted. So dynamically our network structure will change, our data will change, the number of nodes will change, the position of nodes will change, and whenever there is a change, the self-configuration will automatically take place. Because in Internet of Things, we have different nodes connected at different points of time, processing different types of data and performing different operations. And for all those changes, the configuration or automatic configuration of the nodes and everything had to be done. And Internet of Things do all these things. And based on standard and interoperable communication protocols, the configuration, everything cannot be done on any random way. It has to be done on some standard accepted protocols. There are some standard protocols already devised by some consortiums or agencies, and devices have to be connected using those standards. And physical and virtual things have identities. Here in Internet of Things, things means actually it can be a physical thing which has existence. For example, sensor, human being, a camera, anything. It can be a physical thing, or sometimes it can have only virtual identity. It's a virtual thing like software. So which doesn't have identity. That means doesn't have any physical existence, but it should have some identity. And there are some physical attributes for those things. And next, virtual personalities use intelligent interfaces. Virtual personalities will also be there. Client and server, when we say client and server, actually we are saying it as a person, but actually it's just a piece of software, right? So we are trying to create a virtual kind of personality and use intelligent interfaces. When we are communicating, when something happens in one node, it has to be communicated to all nodes, or at least to the nearest nodes, whichever is required. So that kind of intelligent interfaces should be possible. And using all these things, your data, your network, your identity, everything are seamlessly integrated into the information network for performing some operation, right? So this is the basic definition of IoT. And what can it connect actually? It can connect anything at any time with anyone. It can connect from one person manager to anybody. So it can connect anyone at any place, any service, any network. Okay, so it is capable, Internet of Things is capable of connecting all these things. And again, it has four important C's. It has connectivity. Connectivity includes any place, anywhere, any path, any network, and collections. So what does it do actually? So it performs services, any service. It may be an agricultural service, it may be in banking domain, or it may be in space research. It performs any types of service, and also it can be used in any business. And computing, it computes data on what? It computes data on any person or anybody, any device, any sensor. It can be hardware or software, or it can be a person. And convergence, again, anytime, anything, any device. How does it converge, or where does it actually converge? So it can converge or stop its process at any time and at anything or at any device. Okay, these may be new terms for you all. And actually, when we were using World Wide Web, we can choose who to connect, to which device we should be connected. And in Internet of Things, we can choose which device to be disconnected. We can, for example, here you have so many devices around you. You can choose, okay, so these two devices I have to disconnect. So by default, you will be connected to all the things around your network. But if you choose to get you disconnected from some specific devices, it is possible using Internet of Things. This is the basic difference between World Wide Web and Internet of Things. You see how much data has been processed in every 60 seconds. This is actually the statistics taken long before, but now if you take during this corona period, definitely the count would have been emerged so fast. See, for example, in just 60 seconds, 1600 plus reads on script. Okay, so in Skype or now even in Google Meet or Zoom or anything, 3,70,000 plus minutes voice calls, different ads posted on your Craigslist, 98,000 plus tweets. Imagine in just 1 minute we have 98,000, more than 98,000, almost 1 lakh tweets, Twitter counts, new 100 plus new LinkedIn accounts are created. So how many search queries, domains registered, new blogs, 168 million emails are sent, so many. Okay, so in every 60 seconds, so much of data is being transferred across our network. But how do we manage all those things? Huge data storage is required, right? And also there should be an intelligent mechanism to transfer our information in a secured manner over the network. And here, about 15 billion IoT devices are connected to internet, and it is going to be increased every day. And actually, it was estimated last year 50 billion IoT devices are estimated, but now I suppose definitely this is huge. And whenever we are using computers, actually we are using computers, PC, tablet, only 17% we are using computers. Rest of for all our operations we are using only IoT devices. For example, when we are going across a toll gate, we have sensors already installed. So the number plate is all automatically recognized. When we have our fingerprint, when we press our fingerprint on the machine, it reads our fingerprint and marks our attendance. So iris recognition. So how all these things are happening? So all these things we have already connected IoT devices, sensors, actuators. Again, it's a branch of artificial intelligence, right? Okay, and why actually people should go for IoT? It has dynamic control of industry and daily life. So in daily life activities and also in large industries like, for example, car manufacturing. Car manufacturing actually has so many complex operations. right? Even if you want to fit a door in its position, you have to perform so many analysis that longitude, latitude, all those directions, positions, angles have to be perfectly fit. So for these kind of things, dynamic control is very much required, and improve resource utilization ratio. We have only, for example, limited resources. We have to calculate how efficiently or effectively we have utilized the resources, so that if some resources are underutilized, we can alter the resource allocation, and it establishes better relationship between human and nature, and forming an intellectual entity by integrating human society and physical systems. So our human society is getting connected with our physical hardware systems in an intelligent way. And flexible configuration, since IoT allows dynamic or self configuration, it is flexible, so it does its configuration automatically. That means when your node enters into your network, it is stored, its data is being entered, and when it leaves, it is being discarded. So all this configuration will be done automatically. And universal transport and internetworking, so it is again used to transport our data over the internet across the world, internet networking. And it integrates many technologies. Like, for example, if you want to operate a washing machine, so what is the technology behind washing machine, or even if you have a microwave oven, these are the things that we use in our daily activities, right? So when we are using washing machine, it has some C program. Normally they use C program, and then we have some hardware devices, then sensor, time sensor. So everything is included, right? And this is a sample scenario where is commonly used. For example, Maria wants to design a system that will control the interconnected devices in her home via her smartphone. Okay, if I'm tired after complete day's work and I'm sitting in a sofa, I want to switch off the TV. I want to open the door. I want to see who is behind the door. So all those things, right? So she wants the smartphone to be able to lock and unlock the front door, turns off her alarm as she approaches, and controls the light. These are the common things that we need, right? So when we sit in or when we lay in our bed, we want to switch off our light or fan, switch on our fan. It has to be done automatically. But it would be very better. But when if we wake up early in the morning, all our lights should be switched on. And when we go to bed, our lights, everything should be done automatically, right? So we are going into this world. And this is another scenario where when you are entering into a departmental store, when you are just approaching the door of a store, it should open the door automatically. See, when entering the doors, the scanners will identify the tags on her clothing. In tomorrow's situation, we will be having some tags. So in such tags, we'll have our identity, Aadhaar card number, or some identity numbers. So that tags will be identified, and when shopping in the market, see, when we are going, the items or the goods will introduce themselves. Oh, we have this product. So this laptop is here. This salt is here. So this type of soap is here. So likewise, all these things will introduce whenever we are approaching some uh, place in the departmental store. The goods will introduce themselves. Will talk to you, and when paying for the goods, the microchip card will communicate with the checkout reader. So automatically, when you keep your bag on the tray, it will scan all the items that you have bought, and the bill will be automatically ready. And when the particular item is moved out of the stack in the shelf, this will intimate the stock person to keep one more stock product here. So likewise, there are so many examples. Okay, and this is another simple example where car will automatically generate alarm if the driver has made any mistake in driving. So I'm just telling you all these things just to throw some new ideas on your mind to take up some research works or any projects. Okay, so the if the driver has made any mistake, for example, he has not changed or changed his gear or his hand lock, so whatever it may be, it will automatically generate alarm. Even now in most of the cars, if we miss to wear seat belt, it will intimate you. The seat belt alarm will be continuously rising. So till you wear the seat belt, or if you have missed out to take on the handbrake, so it will create alarm, right? So, and another example, the bag will send reminder message if the owner forgot to bring something. So, for example, regularly you are having some products or items in your bag, and today you have stored your phone and you are getting ready to office. It will send reminder that you have missed out your mobile phone, you have missed out your purse, wallet. So this will be very useful in our modern world where we are working like machines. Machines think intelligently like humans, but we humans work like machines, right? And the cloth will tell the washing machine about its requirement for water temperature, different cases. And self-driving cars. See, in India it has not yet evolved, but in foreign countries, self-driving cars are under research and they are introducing more cars. And it would be better if we have a smart parking system, right? So most of us feel difficult to park cars if there is a limited parking space. So you see, USD 41 billion people by providing visibility into the availability of parking spaces across the city. So other foreign countries have invested so much money on developing applications for smart parking system. So for example, if you are in a college or if you are in an industry, and if so many people have brought cars, it will automatically find the free space and park your car there. And we have the most important application, smart city. Nowadays, smart cities. Why I'm saying this is, now we are saying different applications of IoT, and then we are going to integrate how blockchain can be used to solve these problems in IoT, right? So first, in smart cities, there are different applications. You can take up any research idea from these cases. If you're and monitoring and reporting of status of city services. If you have city ambulance service, your transport service, it has to be reported, and every time the message has to be transferred to the concerned person. Traffic flow, if there is an accident in a particular place, automatically all the concerned people traveling in that city have to be informed. Okay, there is an accident happened here and there is a traffic jam, so better you another path. So likewise, the traffic, power, water, gas, road repairs, all these data can be intimated. And government or citizen communication like your license, applying for your license, fees, tax, fines, open access to city information. So how many hotels are there, how many, so where is the collector office, so where is the register office, so all those things. Facilitating third party applications, scheduling and licensing of events, tourism information, smart grid programming. So I need not explain all these things, you can just have a look. Feedback to users on power usage, demand response capability, extension to other resource utilization. So for example, if you are into the world of smart city, where we are paying everything for every service automatically. For example, when we enter into a toll gate, the FASTag system will automatically detect the particular amount from our bank account. But do we know actually where our bank account has gone, that amount has gone? So how the amount is being transferred from our account to the concerned account? So in such cases, we can use blockchain. When there is any security issue or when there is fear of data theft or something, we can use blockchain for efficient and effective data storage, transfer, and also processing in a secured way. So for that concept, blockchain are very much essential. And this is the evolution of IoT architecture. In the past, actually, we were using mainframe. Mainframe was used as the centralized server, and from that, server all the devices, for example, ATM, airline booking, inventory. So all those are connected in the past. But now we are in this trend where every data is stored in cloud. If you have vehicles, your healthcare data, your appliances, so your agriculture data, utilities, satellite data, space research, weather, logistics data. So all those things are stored in the cloud and data can be extracted from the cloud. That is the present situation. But in future, this will be replaced by blockchain with IoT, that is BIoT, where we have the communication established between all the devices or all the networks in your system. Okay, actually some other countries have already implemented this thing, but here in India, this technology is highly booming, and in no time we will get this technology everywhere in our scenarios. Even in a departmental store, this concept will be used. See, when you go to hospital, so your data, your wearables, your logistics, your everything will be automatically, data will be taken, and if you want to pay some amount, it will be paid in the form of cryptocurrency or Bitcoin. So there is no need of taking money. There is no need of taking money. Previously, we were taking money all the time, right? But now we are using our debit cards and credit cards. And this next step, now we are using cryptocurrency, where we actually don't transfer money, but everything is transferred as bitcoins or the technologies that you have used. So this is the future IoT architecture to be integrated with blockchain. And I hope the blockchain principle you have learned, but to my satisfaction, I'm just saying or summarizing the basic principle. When someone requests for a transaction, the request a transaction is broadcasted to P2P network, right? So what is P2P network? Can anybody say what is P2P network? So you would have all gone through sessions, ma'am or sirs. What is P2P network? Blockchain works in a P2P network, right? P2P. What is it? Can anybody say? So rather than just I'm talking, it would be better if you interact so that we can make the session more interesting. And since blockchain, okay, created when two or more PCs are connected and share resources without going through a separate server computer. Yes, we were using client server concept, right? So even nowadays, most of the systems use client server concept, where all our data reside in the server and the client machines communicate with the server to store data and retrieve data. Whereas in P2P network, it is actually called as peer-to-peer, right? So peer-to-peer means, so our data will be connected. So this every node or system is called as a peer, and when this node wants to communicate some data to this node, this can be directly done. So all the nodes, all the peers are connected, and the data stored in any system can be accessed at all systems. That is why it is called as P2P or peer-to-peer network, consisting of computers which are called as nodes. And here there is a process of validation. When there is a new transaction initiated, validation will be done and the user status using known algorithms. So it first validate the transaction whether it is valid or not. If somebody who is not authenticated has requested for transaction, that is not allowed, right? So that validation is first checked, and then a verified transaction can involve cryptocurrency. Okay, so let me ask you a basic question. What do you mean by validation and verification? Can anybody say what's the difference between validation and verification? These are the very common terms that we use in our colleges, right? Whatever may be the department. Can anybody say what's the difference between verification and validation? Yes. Okay, that are used together for checking that a product, service or system meets requirements and specification and that it fulfills its intended purpose. Okay, so actually both are done, but what is the actual principle behind verification and validation? In all the places we will not use these terms. So in some places only validation will be done, and in some places only verification can be done. Right, when we are going to enter a flight, so you are checking in the checking process, what happens? So you will, if you have a bag with you, automatically the system scans all the items in your bag. That is not actually validation, that is verification, where it checks whether is there any item, what are the internal functionalities, what are the things that you have internally in your bag. Right, whereas validation means if verification is over, if for the given input, for that means for the given input or constraints and the final output, it may be a software program or it can be any a product, it can be a car, it can be anything. For the given requirement, if the output is perfect, then it is called as validated. That means that product is said to be validated, and the process of checking or ensuring your output with the input or constraint, given input condition, is called as validation. Input with output checking, that's all. You don't worry about what happens inside. Whereas verification means you will check how, for example, if we give some input, we have obtained some output. For example, 2 plus 3 is the process to be done. We are giving inputs 2 and 3. Finally, if we get the output as 5 and we are checking whether for 2 and 3 we get 5, that is validation. We don't worry about how this 5 has been achieved. But if you are checking how you are calculated 5, you have just used a simple arithmetic operation, or you have created a function, recursive function, whatever it may be. So I'm just saying it in a programming context. You can assume this case in any domain. So the process of checking whether the internal operations or internal functionalities have been carried out perfectly to achieve the required output is called as verification. As Kadirvel said, it's a process of checking that the software meets the specification. Meets the specification means that is validation. Input specification is matching with the output, that is validation. The process that you are doing, it should be time efficient, it should consume less memory. Okay, to be more clear, I want to travel from Erode to Perundurai. Okay, so my starting question is at Perundurai, I want to reach Erode. So when I start here, okay, when your mother is saying, or when your friend or girlfriend, whatever it may be, he's saying that you have to be here by before 10 o'clock. And if you're there at the point Erode before 10 o'clock, it is validated. You have met the input condition, right? Verification means there are different ways to reach Erode from Perundurai. You can travel by car, you can travel by bike or cycle or bus or flight, whatever it may be. Or even you can take 10 minutes, you may take 1 hour, you may take 2 hours. If you are able to reach the destination by car or efficiently, here comes efficiency, and for validation there is a related term called as effectiveness, right? So validation is related with effectiveness, and verification is the process of checking how efficient you have done the process. Okay, so if you have traveled by car, you would have reached the point in half an hour. If you have traveled by bike, it would take 45 minutes. Okay, so if you have traveled by bus, it would take, time is important, memory is important. That means in this case, distance is important. Okay, similarly for different problems, you have different parameters, which should be, sometimes some parameters should be reduced and some should be improved, right? That is maximization and minimization, optimized process of doing something. So that kind of thing should be checked in verification. So here validation means we are checking whether the request is valid or not. That means it should be processed or not. Somebody who is authenticated has raised this request or not. That is done here. And here, after it is validated, we have to check
the internal process, how much amount it has asked for, so is it available in the balance. Likewise, all the internal operations of the particular transaction has to be verified, and it involves cryptocurrency, contracts, smart contracts, records, all those things you know. So for this verified transaction, a cryptocurrency will be generated, and you know the properties of cryptocurrency, right? I need not explain again. It has no intrinsic value and it has no physical form. It's only virtual thing, right? Its supply is not determined by a central bank and the network is completely decentralized. Once verified, the transaction is combined with other transaction. Okay, for example, now you have initiated this block. Okay, so this transaction, now if it is okay, it will be processed here, the cryptocurrency is generated, and already there are some blocks which is running in the system, and now this new block is added to this system. Once verified, the transaction is combined with other transactions to create a new block for the ledger, right? So I hope you all know this term, and this is now added to the existing blockchain. This is called as blockchain, right? So chain of blocks arranged in a systematic way. And once it is inserted, it is permanent and unalterable, right? So it is immutable. The important property of blockchain is immutable. And finally, your transaction is complete. If everything is okay, your transaction is added to this blockchain and the transaction is complete. This is the basic idea. And the benefits, it builds trust. So we can trust the parties and devices. Without trust, it cannot do anything. So the trust is built and it reduces cost. The main benefit of blockchain, it reduces cost, and we are going to relate how this can be integrated with the concept of IoT. Okay, because in IoT area, these are main problems. So, and when we are integrating it with blockchain, automatically the cost reduces. These advantages are seen. Cost can be reduced, simpler and more direct process. Since there is no third party involved, the cost is reduced. For example, there is a farmer who is having 100 kgs of tomato. If he is selling directly to the consumers, he will get at least more money. For example, if he is selling for 50 rupees per kg and its cost is 30 rupees, he can get 20 rupees profit. But whereas if there is a third party involved, he will take 10 rupees, another person will take 10 rupees, 20 rupees, and finally the cost for the actual consumer would be 70 or 80 rupees, and the farmer gets only 30 rupees. So most of the cost will be absorbed by the middle parties, so who just act as brokers. So these kind of costs can be reduced by achieving simpler and more direct process and new business model. So we have simpler transactional model. So and transactions are accelerated. The speed of performing transactions is increased, right? So within fraction of second, you can perform many transactions. Imagine now if you want to transfer amount for some product, if you are buying some product in Amazon or Flipkart, at least you need 5 minutes to transfer money for buying some products. But when you are using blockchain, it will be just in a fraction of second. So you can do so many transactions. And device autonomy. So here there is no intervention of humans. The devices or the hardware devices, whatever it may be, it performs the operations automatically. There is no need for human in the loop. This will also reduce the manual workload. And now we'll see why BOT has evolved. The main property is IoT is a distributed system, right? So when we have a smart home, so all the devices are distributed. We have our phone at one place, we have our remote one place, door one place, camera. It's a distributed system. But today, most of the systems support only centralized infrastructure. Even Google has, to some point, it has centralized structures. Server is located, and from that server only we have local servers and data is distributed. But to make work, to perform our operation on distributed system, this centralized infrastructure cannot support all the activities, right? Like sensors and actuators can talk to each other but cannot execute coordinated tasks. So the sensors and actuators are the terms that we use in our AI context, right? Sensors means when you touch the door, it senses and the door is opened. Some mechanism is involved to open the door, that it actuates, right? So if somebody is hitting our skin senses the signal, sends the signal to our brain, and actually it orders our hand to be withdrawn, right? So our hand again is the actuator, our skin is the sensor. Similarly, in any system, sensors and actuators can talk to each other, but if you don't trust, the actuator cannot initiate the task. Both should work together, both should mutually trust each other, and only then, if my mind is saying, take your hand, remove your hand, if my hand is not cooperating to remove, obviously there is no use, nothing can happen, right? And in this kind of decentralized system, blockchain can help, where mutual help or mutual trust is here. And for achieving this trust, we have smart contracts. Smart contracts can be established and executed across peer group of devices with trust. That's the main important characteristic or property of blockchain. And using this, we can form a low cost and low maintenance trusted ecosystem. When the main reason why people have integrated blockchain with IoT is, since IoT is distributed, so we cannot actually perform some coordinated tasks with trust. To achieve that trustiness, we are integrating this with the help of smart contracts. Okay. And a Gartner study estimates blockchain will add $3.1 trillion in business value by 2030. Imagine how it's booming. And in another analysis, IoT market is also expected to grow from 157 billion to 457 billion. Actually, again, this should have been raised than discussed. So both are increasing separately, but now they are both increasing together. Okay, this is another example where this blockchain and IoT are used together. See, you can just imagine a situation like this. I don't know whether in the previous sessions this kind of example are given. If it is already given, kindly ignore this, or you just have a new idea. Just-in-time manufacturing. So where all manufacturing are done using 3D printers. There is no inventory mechanism involved. Okay. For example, this case, you see a car in a road. Okay, you are going to office, you are seeing a car in road, and you want to purchase this car. So what you will do, you just take photo of that car and upload to this just-in-time manufacturing portal. So this is actually again another important area where if you post some photos, that device or that machine or whatever it may be, that will be automatically manufactured and delivered to your address. Okay, so we take photo of the car and upload to that portal. What happened? The request is received at fulfillment center. Okay, so when we submit our request, it is received at their server, fulfillment center, and based on that, the photo of the car, for example, you have taken photo of Rolls-Royce car and uploaded. So automatic 3D modeling of that model that you have given is done, and the software is used to design that. And then this job is transferred to 3D printer, and now the modeling is done. Then it should be provided or transferred to laser cutting machine. The parts have to be cut, right? So and then required tasks are performed. Now the car is manufactured. The job and material transferred to other unit organization using drone or driverless vehicle. For example, for manufacturing car, you need door, engine, gear, so many parts. All these are transferred from different locations using drone. Okay, or you can be using driverless vehicle like your automatic cars, and also the job. And more designs and tasks performed in one unit and transferred in another unit, transferred to another unit. Finally, all these things are done, and now the car is ready. The final product have to be shipped back to user. For example, I am sitting in E Road and I have ordered for a car. The manufacturing unit might have been, for example, in Delhi. Okay, so from that place, it will be manufactured and it has to be transferred to different locations to reach E Road. Actually, this is called as logistics, right? And blockchain is very much used in logistics, supply chain management, where if you are simple example, if you are ordering for some product, watch in Flipkart, what happens if the product is available at E-Road stock center, it will be directly delivered to me. If not, it will be checked with Coimbatore. If not, it will be checked with Chennai and then Mumbai. So if it is not available at any place and it has to be imported from California, so this data should be transferred, right? Our amount should also be transferred to that location, and the product has to be transferred from California to Europe. So to reach this destination, we have so many connection points, right? So much cost is involved. And after this product is reached, for example, this watch, and if it is damaged, what happens? I'll just give back that product, that this is damaged. If this is damaged part, again what should happen? It should be transported back to the original location. And for this, if I would have already paid cost, okay, and again there are so many, I have to repay all those things that will be refunded. So there are so many tasks involved. If it is a cryptocurrency, I will pay only after the product has reached me safely, right? This is how blockchain are useful. And this is the same example. The order is placed by a user, a smart contract is generated, the CAD design is done. Okay, so for example, this design is done for the smart contracts, and this job is moved to some other units, required number of units. Finally, all are assembled, and now the car is ready for shipment. Now you can transfer this to the desired location. And how this is transferred? It requires distributed trust system. When I'm doing some operation here, I should trust this person and also this person. It may be a person, it may be a unit, or it can be anything, right? I should trust the related sources. And each unit must operate autonomously. These are important properties. A group of devices must operate autonomously, and each unit must perform the task and complete the contracts. So these are the things that you know. And final, all the systems, all the process, all the units in your entire network will have the common goal of manufacturing a car. Similarly, in any blockchain environment, its goal is to provide secure transmission of data and payment of money, right? And smart contracts are nothing but protocols that facilitate, verify or enforce negotiation or performance of contract. Okay, you know this? Okay, why again? So it's a game changer. It has introduced a stronger working relationship with your partners. This is nothing but the trust is built, and greater efficiency as partners take advantage of the information provided. Since everyone in the system trusts each other, the information provided can also be trusted, and there is a greater efficiency between partners. They take up more work with less time and with less cost. And it enables IoT devices to participate in blockchain transactions. When we are performing blockchain transactions, here IoT devices are also used. For example, sensors are used to transfer amount as Bitcoin or cryptocurrency, and reimagine the world's most fundamental business interactions in the form of digital interactions, and the cost is reduced. And see, in 2016, the blockchain was not this much common, but now it is so much improved. It is estimated growth from to $10.2 million to $2,312.5 million in 2021. Imagine how fast it has evolved, and this is improvement. And blockchain, in 2016, this blockchain IoT was in an exploratory phase. And there are so many companies which are directly involved in BIoT applications. And the stage is only innovation. It has not yet completely evolved. It is in the innovation phase or exploratory phase. More and more companies are working towards development of new solutions. And big players who have invested in BIoT are IBM, Cisco, Robert Bosch. Okay, these companies are working to a large extent in this area. And there are many startups also. See, these are some of the startups which are working in this area, and the opportunities are it can be used in power grids, because whenever there is a transfer of data or amount or something through different points, different nodes at different levels, there is a opportunity for BIoT, blockchain, right? Healthcare, IoT platforms, shared economy, even in share market, stock market, we can use this, and insurance. For example, if I want to claim insurance, it has to be transferred through different teams, different people. First, I have to submit my data to hospital. Hospital has to confirm with the health insurance. They have to so likewise, so many entities are involved, right? So everybody should trust each other. Only then the process can be complete. And then supply chain, right? Delivery of gold. For example, if gold is imported from Dubai to India, okay, see how many points it has to cross. And somebody wants to say any doubt? Okay. And industrial IoT is another area where we have used IoT in industrial applications for like car manufacturing, your robots, all those things. And these are different applications of IoT. First, we can have it. We can use it in government, democracy, and law enforcement. In government policies or government operations, we can use telecommunications and information systems. You can just read, and defense and public safety, military purpose also you can use, in farming, financial transactions, collaborative and crowd sensing. For example, in this COVID-19 situation, we have to maintain that social distancing, right? So all those kind of things can be checked. So whether people are standing at 6 feet distance, whether all are wearing mask, or all those kind of things. Smart cities, healthcare, industry, personal sensing, smart living, logistics, fleet monitoring and management, smart objects, transportation, energy. These are different applications where BIoT are applying. I'm not saying about blockchain or IoT separately. So I'm saying about BIoT applications. And again, these are the relevant factors that condition the development of BIoT application. See, just infrastructure. Whenever we are going to develop a BIoT application, some features have to be first considered. First one, infrastructure, right? So this blue color with infrastructure. Infrastructure means it should manage the address management, network administration is involved in infrastructure. Next, mining. Mining is also an important process in BIoT, right? So in blockchain, not only in BIoT, in blockchain you have a miner and a mining concept. So in mining you have boycotts, hash functions, and mining equipment. So mining equipment can be CPU based, GPU based, FPGA based, this mining. And next, adoption rate, latency, versioning. These are different factors to be considered. Next, throughput. So the transaction speed and block size, smart contract and legal issues involved. So usability of your application, multi-chain management. If you have multiple chains, how it is managed. Privacy, and there is so much to consider in privacy issues, privacy and security issues. Privacy, security, forks, bandwidth, energy efficiency, blockchain size. See, all those things I have circled or important parameters, and the other things are the related parameters. All these factors have to be considered whenever you are starting a BIoT application. And the types of blockchains, I think you have studied, but just public blockchain means anyone can join the blockchain without the approval of third parties, being able to act as a simple node or as miner or validator, right? So anybody can join, and the miners are usually given economic incentives like Bitcoin, Ethereum or Litecoin private blockchains, and the owner restricts the network access. Whereas in private blockchains, they are permissioned. That means they will be given permission or they will be revoked permission. Okay, in order to control which users can perform transactions, carry out smart contracts or act as miners. If we have our Google Meet or Google in our college, actually our college has restricted access. Only the people in this particular institution or organization can use this mail ID. Similarly, private blockchain gives control or power only to some specific users who are already agreed upon, and they can only perform smart contracts and they can act as miners. Others cannot do these things, but not all private blockchains are necessarily permissioned. Okay, and this is the blockchain taxonomy where public, so this is, so on the left side we have public or permissionless blockchains, and the right side we have private or permissioned blockchain. Okay, so in this public blockchain, again you have token based and token agnostic. Token based means everything will be based on tokens. See here, logic oriented blockchain. There are two types. In public and private, again we are categorizing. This is a classification of blockchain. Logic oriented blockchain and transaction oriented blockchain. In logic oriented blockchain, we are using Ethereum. Ethereum, you know, Next, Counterparty and Burst Coin are all working based on this token based logic oriented blockchains. Whereas this Litecoin, Bitcoin, Zcash, Dash, Monera are working on transaction oriented blockchains. Okay, and this private things, Monax and Ripple. And token agnostic. Token agnostic means, what is the meaning of the word agnostic? Can anybody say? What is meaning of the word agnostic? It's a new term. Agnostic means if you say there is God, it's hard for you to believe whether God is there or not. That means doubtful. So if you are not trusting, if you are not confined about, okay, whether to believe this token or not. Okay, so that means you are afraid of using tokens, that is token agnostic. So you don't use these tokens. So here you have root stack. And when you don't believe in tokens or trust in token, there is no transaction oriented blockchain, only logic will be there. Okay, and here in private, we have hyperledger fabrics and multi-chain. Hyperledger, again, a common term in blockchain, right? And when blockchain and IoT are interacting, there are three different types of approaches. See here, the first case, you have IoT to IoT interaction. So this is an IoT device. Here you have a computer, here you have a fan or something, you have another IoT device, right? So this solid line represents data flow and this dotted line represents interaction, right? So here, for example, if you have the starting point, you have data is initiated from this place, it is transferred to the blockchain, and again some transactions are being carried out, and see, it can be transferred here in this network or here, or it can be in any direction. Finally, it has to communicate again with IoT. That means now our purpose is to establish interaction or communication between one IoT device with another IoT device. But this can be done with blockchain as a middle point. Blockchain will be in intermediate positions, but our source and the destination will be only IoT devices. In between, you can have blockchain. Okay, so this is one type of architecture or of interaction. Next, IoT blockchain, where you have many IoT devices, all of which interact with your blockchain. See, this car is interacting with blockchain device only, and it doesn't have any interaction with another IoT device. All the IoT devices interact directly with the blockchain environment. That's it. And the third approach, I think it's very important to remember this architecture, because in future when you are developing an DIoT application, you have to choose any one of these architecture based on your problem scenario, right? In this hybrid approach, it can be anything. It can be IoT or IoT blockchain. So here watch interacts with blockchain. Next you have fog computing model, and you have cloud computing model, cloud structure. So it is communicating with another system. So see here, it's a washing machine, it's a fridge. So hybrid approach means combination of different types of interactions. I hope this is understood. And these types of architectures, IoT means it is fastest. If you have this structure, it is fastest in terms of latency and security, since it can work offline. So sometimes it can transfer data here, and afterwards when it receives data, the receiver side performs transactions, right? And it have to be able to communicate with each other, which usually involves discovery and routing mechanisms. And again here you have to identify the routes, right? So routing mechanism is highly involved. And only a part of IoT data is stored in blockchain, whereas IoT interaction take place without blockchain also. So as we can see, only for some operations blockchain will be involved, and for some operations these devices interact directly also. IoT blockchain means all the interactions go through blockchain, enabling an immutable record of transactions. Can you say what is an immutable record of transactions? Anybody? This is an important property of blockchain, right? I'd be happy if any one of you answered for this so that we can make it interactive. Okay, cannot be modified. Very good. So immutable means once it is created, it cannot be modified. That means whenever we are making a transaction, the details of those transactions can only be seen. It's like read only. We cannot make any alteration. So this property is very much essential, because in blockchain environment, so many parties are involved, so many people will be involved. If somebody wants to change some data, it should not be allowed, right? So for this property, again we have this immutable. So once created, the data or transaction will not be modified. It can only be seen. And this approach ensures that all transactions are traceable, as the details can be queried in the blockchain, and it increases autonomy. And hybrid approach, combination of all these things, right? So, and this flowchart explains what type of blockchain to use in an IoT application. So we have seen public, private, right? So in which situation, what type of blockchain has to be used? First step, you have to check, is it necessary to use a blockchain for my IoT application? This is the first question. If it is necessary, you have to check, are there copies of the ledger? Ledger means, normally the traditional ledger means the note that you have, the notebook or something that you record your data or transaction, right? So you have to check whether there are any copies of the ledger. If there is a copy, or redundant copies need to be distributed in multiple computers. Okay, hot piece, it can be an Excel file that you have already created, or it can be a note, or it can be anything. If required, you have to check whether the same copy have to be duplicated and distributed in multiple computers. Okay, so if the copies are not there, a traditional database should be sufficient. That means if multiple copies are available, then obviously it has to be integrated. That means all the copies should have the same data. And if there is no copy, only one copy, a normal database is enough. And here, if it has to be distributed, do all the IoT entities trust each other? If I'm going to share my salary details to a system of people, to a network of people, I have to first ensure whether am I trusting the other person. Only if I trust my neighbor, I will say share my data, right? So this kind of things is here. So whether all the IoT entities trust each other. If yes means a traditional database is sufficient. Okay, so if there is no trust involved, and would IoT entities trust a third party? Okay, so if we are 5 people in a team, we don't trust each other. What we'll do? We'll go for a third party. Okay, so if we trust a third party, okay, so yes means a bank, government or middleman may manage the data. We provide our data to a common person who we all trust, right? So that can be a bank or anything. Okay, so if I have 5 lakhs of amount with me, and if I'm afraid to give the money to you, okay, so I don't want to have it on you or my friend or whoever it may be, so I'll just deposit in the bank or in a post office or mutual fund or whatever it may be, right? The same case here. And if the third party is also not trusted, then or the IoT device is going to be deployed in a restricted network. If 50 people are in a team and I don't trust anybody, and also I don't trust third party, means I have to do my services or operations in a restricted network. I have to share only with my 5 friends or 4 friends, right? My network will be restricted. And if it is going to be deployed in a restricted network, is it necessary to control who can update and maintain the blockchain? So whether there is a need of manager or control person who manages all these things. Okay, so if it is necessary, you can use private permissioned blockchain. If these kind of situations, so I will share the slides with you. You can get a better idea of when to use these 4 kinds of blockchains. Okay. 2 kinds of blockchains, private permission, and if it is not necessary for control, so you can give private permissionless blockchain. Okay, so in private blockchain you have permissioned and permissionless. Okay, so here if there is no control, you can give permission to all. If there is a control, then appoint a person to grant and revoke permission. And this case, not in a restricted network, means you can go for public blockchain. Okay, in public blockchain, if there is a need for constant updating and maintaining, go for public permissioned blockchain. If constant maintenance or updation is not required, go for permissionless blockchain. Okay, so these are the cases. So based on your problem scenario, you have to choose these different types of blockchain for your IoT application, right? Okay. And again, you have a new term. So Internet of Money. Even while preparing for this presentation, I have come across so many new terms that are totally new to me. Internet of Money, we have learnt about Internet of Things, right? But Internet of Money is a new terminology. It means that it proposes a set of 5 layers that operate on TCP/IP. So this is your OSI layer, right? So your network, this is the normal TCP/IP model that we all know, starting from our physical layer, data link, network, transport, session, presentation, application layer. These are the 7 layers in our OSI model, TCP/IP model. But here IOM means Internet of Money. It is nothing but blockchain stack. Internet of Money means at the bottom you have TCP/IP protocol suite. On top of that TCP/IP suite, we have 5 more layers. First, you have ledger layer. Ledger layer creates ledgers and issues assets. Okay, you know the purpose of ledger. So it creates that. Next, payment and exchange layer. If you want to pay amount, so here no physical amount is involved, right? So everything is cryptocurrency. It's Bitcoin, right? So payment and exchange layer. And next, pathfinding layer, which calculates the optimal set of atomic transactions to be executed for the desired value transfer or exchange. So which calculates the path, okay, and also the atomic operations, the optimal set of transactions which are required for performing some transfer or exchange. And finally, you have contract layer, which controls balance through certain running node. Okay, and at the top you have application layer. In between this, you have this 5 layers included. This is called as Internet of Money. Next, IoT challenges addressed by blockchain. So what are the, and again, whenever you are implementing an IoT application, there will be so many issues and challenges, right? Some issues are specifically addressed by blockchain. The 3 important issues in any IoT scenario is security, scalability, and privacy. These are the 3 important critical issues in IoT scenario. Security means plethora of device identity solutions. Okay, so device should be identified. So if we have so many keys, which key is valid, which key should be used where. And next, the need for certification authorities. So who should issue the key, public key or private key, or who should issue the key or certification. Next, communication from edge computing to cloud computing. So in all these cases, security is in danger, right? That means that there are so many possibilities of attacks, hackers. Next, privacy means in privacy context, you have centralized data management and need for trusted parties. So when you store data, there are many possibilities, or there are high possibilities that data can be seen by somebody else who is not actually authorized. Your privacy is lost. And when you transfer data over your network, and again your privacy can be lost to some extent. Exposure of data flow in the network, right? And in scalability is nothing but you want to increase the size of your network or structure, right? Scalability in general means increasing the size or decreasing the size, right? So here, when everything is centralized control, when the control is totally centralized, when we increase nodes, it is difficult. For example, we have only one server and already we have 50 clients accessing the server. Okay, if I am going to include 100 more clients, what happens? 150 clients will be accessing the same single server. If the single server is capable of holding all the requests, then it's okay. If we have not designed our server to adapt to that scalability, then it's a problem. Then the entire server has to be changed, the entire structure has to be changed, right? So these are the 3 common issues in IoT scenario. There are many issues, but these are the 3 key issues. And for this boxes represent the solutions provided by blockchain. So trusted device identities. Okay, so for ensuring security, we have device identities in our blockchain. We have smart contracts, right? So we have trustiness. The main important property is we can trust each other, because when you change something or when you introduce a transaction, this transaction history is stored in all devices in your network. So even if you change, all other systems get updated, right? So there is no possibility of updation or doing any modification later point of time. And the device can be identified easily since there is no modification. And decentralized control. So there is no centralized mechanism. We have peer-to-peer network. So the control is decentralized. And privacy, secured decentralized storage. Since data is stored in a decentralized and distributed form, it's secured. And its privacy is also ensured. And how blockchain benefits IoT. So actually we have seen these 3 important properties as a overall, but we'll see how this can be achieved. Okay. So blockchain is a missing link to settle privacy and reliability concerns in the Internet of Things. Can anybody say what is reliability? You know, privacy. Blockchain actually serves as the middle link to settle these things. Okay, so what is reliability? Can anybody say what is reliability? Yes, a common terminology that we are all using. What is reliability? Okay, so very good. So trustiness. In Tamil we call it as Nambagatanmai, right? So when I have a secret, when will I share my secret to you? Only if I trust you, right? So that you will not share my secret to anybody else, right? So this is an important property of Internet of Things, IoT scenario. It's an important thing, right? Reliability. And this reliability is very much essential to ensure privacy also. And it can be the silver bullet needed by IoT industry. It can be used in tracking billions of connected devices. Even if you have billions of devices connected together, so it can be used. Blockchain can be used, enabling transactions and coordination between devices. For example, take a simple example of Flipkart. Okay, so this Flipkart or Amazon. Okay, so Amazon has orders placed all over the world, right? So it is spread all over the world, and orders will be placed from all points, from all locations in almost all the countries. So how all the products are delivered perfectly to the particular destination center? There is a mechanism to transfer data, and that means money, and also transfer products from one location to another location through the optimal path, right? So this transaction coordination, everything can be done, and here there are so many devices involved. Even billions of devices are involved in just Amazon transaction itself. Okay, and this will save the cost for IoT industry manufacturers. And this decentralized approach would eliminate single point of failure. So since it is decentralized, if one system crashes, if one node fails, obviously nothing is lost, because the same data is already replicated in almost all the systems in your network, right? So more resilient ecosystem for devices to run. Resilient means when something goes wrong, when one node crashes, we can take the values from some other nodes. It is duplicated, right? Then you can use cryptographic algorithms. In the programming concept, actually we'll be seeing how to develop simple blockchain program. In that we'll be using encryption and decryption algorithms. Okay, so cryptographic algorithms are used to ensure that data is more private. Okay, so in Ethereum, I think yesterday you would have studied about that hash values and all. It's like your digital fingerprint signature. So there the cryptographic concepts are used, and the ledger is tamper-proof and cannot be manipulated by malicious actors, because it doesn't exist in one single location. It is distributed at all nodes, so it is not located in one location, and hence man in the middle attack is not possible. So you know there are different types of attacks, right? So this man in the middle attack is a common attack. So this is not possible in blockchain enabled IoT system. And it makes trustless peer-to-peer messaging possible using currencies. So I need not study all these things, you know these things, I'm just telling you the keywords here. So you are using cryptocurrencies without the need for third-party brokers. That is the important thing here. And this decentralized, autonomous and trustless capabilities make it an ideal component for IoT solutions. And these enterprise IoT technologies are highly improving. And it can keep an immutable record of history of smart devices, and hence autonomous functioning is possible. So since the data is available everywhere, it need not wait for control or order from a centralized system. So it can start its process autonomously at any time, right? And blockchain opens the door to a series of IoT scenarios that were remarkably difficult. So in IoT, in difficult situations, blockchain creates more opportunities, right? So it provides secure, trustless messaging between devices in an IoT network, and that is why BIoT is booming nowadays. And it messages between devices similar to financial transactions in a Bitcoin network. Okay, and to enable message devices, smart contracts are used. It has the ability to maintain duly centralized trusted ledger of all transactions occurring in a network, and hence IoT, industrial IoT applications are commonly using this, right? Okay, so and how blockchain is used for security in IoT applications. Identify management blockchain based PKI eliminates need for centralized system. In security, normally you will be using key, right? We will be generating private key, public key, hash key. We will be transferring this key first. We will be encrypting all those things. So there is a decentralized approach, and it eliminates the need for centralized system for managing all those private keys and public keys. Okay, and there is an integrity management. There is a good possibility of integrity, and here we don't use keyless signature structure using blockchain. A signature will be generated, but we don't have explicit private key, public key, and maintenance of all those keys. Okay, and it reduces different types of attacks using blockchain based network services. Almost most of the attacks are avoided in IoT devices. Okay, and this slide actually discusses where blockchain can be used. Okay, see, it can be used to create secured mesh network that will allow IoT devices to connect securely and reliably, avoiding threats of device spoofing and impersonation. So when you want to avoid this spoofing and impersonation and want to create a mesh network with IoT devices, you can use blockchain. Actually, implementation of blockchain is little bit costly. That means you need a more expert to implement blockchain. Maybe after 5 to 10 years, many experts will be available, but for now, there are only limited blockchain developers. So it is again little bit costly also. So you can choose blockchain when it is explicitly required. And every IoT node can be registered in the blockchain. So for example, if you have a watch, your TV remote, your TV, your door, everything, all the nodes in your IoT devices should be registered in the blockchain, and each node will have a blockchain ID. Okay, and remember all those things because these will be used when you are going for program. Okay, we will have a blockchain ID for every device which uniquely identifies a device in the namespace, and for a device to connect another device. For example, okay, this is one device and this is another device, this is another device. We have 4 devices. Every device will have its unique ID, right? Every device will have unique ID, and if this device wants to connect to this device, one will use the blockchain ID as URL. So how this identifies this device? For example, this device ID is 1 and this device ID has 2. It will use the blockchain ID as URL. When I want to traverse from google.com to yahoo.com, so I'll just type the URL of Yahoo, right? So similarly, if I want to connect to this blockchain ID 2 is used as the URL, and will use its local blockchain wallet to raise an identity request. It will raise a request to get connected to this URL. That means the device. This wallet will create a digitally signed request. This digitally signed request means a encryption kind of key. A hash value will be created. Okay, that we will see when we see programs. Okay, that request will be created and sent to the target device, which will use blockchain services to validate the signature using public key of the sender. And again, we know there is no need of explicitly creating keys. Okay, the system will automatically create key and it will update the key. Everything will be done automatically in blockchain. Okay, and in this way, M2M authentication can take place without the need of centralized arbitrary or service. So here, the system, the devices itself sends rises request, authenticates, validates, transfers, everything is done automatically, and there is no need of centralized mechanism or a person to control all those things. Okay, and for a device that is constrained by a resource, can be connected to proxies where the wallet can be stored. For example, if there is a constraint on a resource, it can be connected to proxies, and the proxies can be located in the wallet. Okay, and this will introduce some form of aggregation. Actually, when we use the concept of aggregation, aggregation means normally we'll call it as sum, calculate, average, max, min, these kind of operations. Like, so suppose if we have restrictions on some data, we can go for this form of aggregation, and this will be used for wide range of IoT services. And examples: vehicles, logistics, transportations. So all these cases we use blockchain integrated with IoT. I hope until this point you would have gained a basic idea of why to integrate blockchain with IoT, where to use, what type of blockchains to be used in which scenarios, right? Yes. Is there any break for the participants, or I can continue directly? Kadir sir or ma'am? Yes ma'am, when is the break ma'am, or I'll go to...
Ma'am?
Yes ma'am, when is the break time?
Ma'am, there is no break time. If you want, you can leave for 5 minutes and you can join again, ma'am.
Okay ma'am.
Okay.
Okay, I'll just complete the slides now within 10 minutes, and we'll have a short break for 5 minutes, and then we start programs, okay? And now we'll see distributed blockchain architecture to solve. Okay, ma'am?
Okay, ma'am.
Okay. So distributed blockchain architecture is used to solve security and trust challenges. So now in this slide, even though it's clumsy, I just want to put all the points related to this thing. So when there is a security and trust challenge in IoT scenario, we'll see how this distributed architecture resolves these problems, right? So when the sensor data measurements are there, it can track. Blockchain can track the measurements on the sensor data and prevent duplication with any other malicious data. So for example, if the sensor measures the data on any device, there are possibilities that the same data may be duplicated. Blockchain can just prevent that duplication, right? And deployment of IoT devices can sometimes be complex because some devices are actually very complex and involve many structures. And in such cases, a distributed ledger is used to provide identification, authentication, and secured data transfer. And instead of going through a third party, normally when IoT devices are connected, third party devices will be used for ensuring security. When blockchain is there is no need for third party. Just blockchain, that wallet, smart contracts, everything will take care of that security. And distributed ledger, normally ledger will be used which is centrally located. But when we are using blockchain, there is a distributed ledger which is shared among all the nodes. So it eliminates a single source of failure within the ecosystem, protecting a device data from tampering. You will not lose your data at all. Almost all the times you can protect your data. And it enables device autonomy, individual entity integrity, and supports peer-to-peer communication by removing technical bottlenecks and inefficiencies. And the deployment and operation cost can be reduced. IoT devices are directly addressable with blockchain, providing history of connected devices. Again, this is another important feature. It maintains the history of all transactions the history of all devices that are connected, right? So at later point of time, if you want to see how many networks have entered, for example, if you have mobile network, Reliance Geo network in Erode, you want to see how many mobile phones with Geo network has entered into Erode city today. The history of all these things can be seen, right? So blockchain based IoT solutions are suited for simplifying your business process, improving customer experience, and achieving cost efficiency, right? So this is the advantage of using the distributed property of blockchain. And for addressing problems in IoT, we are using blockchain, fine. But blockchain itself has some challenges, right? So whenever there is a technology, obviously it has both plus and minus. The challenges here are legal and regulations. So legal issues are there when a ledger is issued, when the data is transferred, when the cryptocurrency is transferred. There are some legal policies and regulations which are involved, and that is not actually standardized till now. That's the problem, and it is not globally accepted. And technology, which technology to use? There is no established standards, there is no standard transaction processing time, and the storage is decentralized. So which technology can be used? So that's also a major challenge. And if some technology is suited for blockchain, is it available with the customer? Is it available with all the users of that network? Next, fragmented market. Fragmented market means the market is divided into different pieces, fragments, right? And we have to target the particular market. For example, onions may be sold very much in Europe, but it may be sold only less amount in Perundurai, or it may be more high, even higher in Coimbatore. Right, the market sections are fragmented and it has different properties, different trends of behavior. So we have to analyze all those things. And important thing, lack of skills. Not all the users or people know blockchain. First of all, people don't trust blockchain nowadays. Only it's evolving, but even many people are afraid of going for cryptocurrency and bitcoins because they don't have any technical knowledge or the general knowledge about the blockchain. Even this is a new topic for all of us. So if we say artificial intelligence or networks or smart networks, these are the common terms that we are using. But blockchain, this is a totally new area and we don't have much knowledge, right? So that's the problem. And when we are implementing DIoT, okay, so I'll just take break for 5 minutes and come. I mean, just take 5 minutes break.
Okay, ma'am.
Okay, ma'am.
Participants, you can take 5 minutes break and you can back be 11:35 or 11:36.
shall we start again? Are you all here? Shall we start, ma'am?
Yes, ma'am.
Okay. So when we are implementing BIoT application, again actually there are some challenges. So we have seen so many challenges in different scenarios. First we have seen the challenges that are in IoT. And then there are some challenges involved in implementing blockchain. And sometimes blockchain can be used to address challenges of IoT, like your security, privacy, scalability issues can be addressed by blockchain. But now, when we are implementing an IoT application, again there are so many challenges, right? So the main challenge is scalability, right? Because most of the systems are centralized, and when we go for decentralized system, so how the cryptocurrency should be transferred, how the cryptocurrency, bitcoins, everything are transferred, processed. That's the thing. Next, processing power. Here there will be a secret key, hash key generated for every message that you are sending. For example, I am saying, hello, good morning. This is the message that I am transferring. And for this message, some hash key will be generated. Likewise, for every message, some hash key is generated, and there is some processing time and power required to perform this process, that encryption, generation of key, all those things, right? So that's also important. And IoT ecosystems are very diverse. So it may be, some device may be located here, some other device may be located at Chennai, some may be at Mumbai, but my entire system should be connected. So how the entire blockchain can be processed across all the nodes in your system. And in contrast to generic networks, IoT networks are comprised of devices which have different computing capabilities. That's a very big challenge. For example, you may integrate devices like your washing machine, fridge, watch, and your smartphones. So each will have different processing capabilities. Your processing or your operations of watch is different, washing machine is different. Here you might have implemented in C, that language has Android. Some other may have Python. Okay, so how they are all integrated together? And not all of them will be capable of running the same encryption algorithm at the desired speed. If you have included one mechanism to encrypt your key, that means to generate a random key, this cannot be decrypted at the same speed at all devices, because when you are using washing machine, so it has only limited processing speed, it has only limited RAM memory, means obviously it takes more time. When you are using smartphone, it will decrypt very fast. When we are integrating with a laptop or a supercomputer, it will be very fast. So the speed will be mismatching. Sometimes it will create problems. And storage is also a hurdle, because all nodes store details of all the blocks. So the same data is duplicated everywhere. Even though by doing this security is achieved, nobody can alter the data without knowledge of others. That property is good. But we will be storing so many copies of the same data at all the nodes. Okay, that storage has to be considered. And it eliminates the need for a central server to store transactions, but the ledger has to be stored on the nodes. Okay, and this ledger size will increase as time passes. And the same thing, when we are using some simple devices like sensors, these sensors cannot store huge amount of data, right? So the storage space will not be sufficient. And this lack of skills, only few people understand blockchain technology. So what happens when you are, what is meant by Bitcoin, cryptocurrency? Since everything is virtual, it's very difficult for normal people to understand how actually it works, right? Okay. And legal and compliance issues that we have discussed already. To solve this, we have the concept of Hyperledger, right? So it's actually an open source project. It's a protocol. That means it's a set of rules for performing business to business and business to customer transactions, right? These are some rules or standards, that's it. It takes a novel approach to the traditional model by managing the admission of participants at its core. Okay, so when a new person, when a new node is entering, so how we are introducing that new node into our network, how the data is again copied to that particular node. So all those things are very critical, right? And again, it's a permissioned shared ledger. Hardware ledger is controlled by some persons. That means there will be some manager or somebody who gives permission to persons who are going to update or access this ledger, and this will be shared, and it saves computation cycle. Usage of hyperledger saves your computation cycles, scales well, and responds to industrial use case requirements by providing robust model for identity, auditability, and privacy, right? Okay, and now we are into programming perspective. So these are the basic idea about blockchain and IoT. Now we'll see how many tools and languages are used to achieve these concepts. You know Bitcoin and Ethereum, right? So the three important principles for designing is scalability, decentralized, and consistent. These are the three properties for any blockchain design, right? And when we are using public blockchain, we have the property. To achieve this decentralized and consistent property, we are using Bitcoin and Ethereum. Ethereum is a commonly accepted language or framework for performing this blockchain programming, and Bitcoin is also used. Okay, so these two are the very common things. But nowadays, many technologies are being evolved, but till now, these two are the common frameworks which are used by people to achieve these both decentralized and consistent properties. Okay, so and okay, front end you can use any language. So for example, I can see, okay, these are different, okay, these are the different programming languages when we are using blockchain. Even if you know JavaScript, that's okay. Even C++, C sharp. Okay, so many people are using C++. These are the languages that we know, that we commonly use. That's why I am highlighting this: C++, C sharp, SQL, JavaScript, JSON, and next you use Python also. Okay, so PHP, Ruby, Python. These are the common languages that are used in blockchain. We have some other languages here. So Bitcoin scripting language, low-level LLL, Lisp-like language, Viper, Simplicity, Verna, Obsidian, Solidity. The Simplicity and Solidity are also very commonly used after this JSON and Python, JavaScript. Next, these are Roland, Michelson, Plutus, Sophia. Even though these names are very new to us, but these are the different languages used in different scenarios of blockchain. But the common languages that we know are C sharp, SQL, Python, JavaScript, JSON, PHP, Ruby. Okay, even Golang, Rust are also used. Golang and Rust are new languages, right? Okay, but when you are thinking about database, so which should be used? Actually, when you are designing a blockchain, this will be your programming structure. So at the bottom you have the database layer, and on the top you have blockchain layer, and above it application layer is available. Database layer is nothing but which stores your data, which is like your normal structure, software structure, front end back end structure. First, database layer. Which database to use? Actually, again, there are so many databases, but commonly MongoDB is used. Okay, so I'll say why MongoDB supports this blockchain database structure. And next, blockchain layer, and then application layer, you have your front end forms like your JavaScript or Python type forms that you are designing for any application, for supply chain, identity management, financial transaction, stocks, or agriculture, or any application. Okay, and in blockchain layer, what do you have? What are the functionalities of blockchain layer? It performs decentralized administration. So all the programs required for performing this decentralized administration is written in blockchain layer. It will be controlled by this. And next, immutability property is also handled by blockchain layer. And asset transfer. Asset transfer means you are transferring some assets from one location to another. For that only you are again paying paying the amount for the delivered asset in the form of cryptocurrency, right? That asset transfer is handled by blockchain. These three important operations are handled by blockchain layer. And the bottommost layer, database layer, it should have rich queries. It should support complex queries, and it should be scalable, and data should be distributed, right? So there should be appropriate mechanisms for scaling up your data. That means increasing your data size, and also how effectively data should be distributed. Next, enterprise hardened. When we have enterprise data, normally, for example, if you are working for ICICI Bank, that's an enterprise, right? So every day industry or every enterprise will have its own structure, and we should follow their norms and their rules and protocols. That should all be enclosed in your database layer. These are the two important layers here. And on the top you have application layer, right? And when you are implementing, these are the common patterns. First, when you are having a distributed database, this is normally without using blockchain. I'm saying the left side without blockchain, and the right side we have blockchain integrated. Okay, so normally when your database is distributed, we'll use MongoDB. MongoDB can be used for any distributed, and it's a NoSQL database. I hope you all know this MongoDB, Cassandra, right? So all those things, these are NoSQL databases, which is suitable for unstructured data. Again, these are concepts in big data analytics. Yes. So here you have an admin which controls the operations. In between you have a Mongo database, and from this database all the clients will be accessing their data. And in this blockchain database or big chain database, you have the same MongoDB. You can use MongoDB, which is very much suitable. You can use some other databases also, but it's very commonly used. Okay, here instead of one admin you have many admins, co-admins. Okay, so and these co-admins control the operations of your database, and from this database all the clients will access their data. So this is how the database structure will be implemented, and the requests for those database can be executed, right? And why we are going for MongoDB for blockchain database? Blockchain contains huge data, right? So, and again the data will be in different format. So some may be in Excel format, some may be in text format, or some may be in database format or anything. So for this kind of blockchain database, structured database or structured database structure like your relational table, Oracle will not be suitable. So you have to opt for NoSQL database. Among these NoSQL database, MongoDB is highly suitable for this, since it has expressive query language and secondary index. This sleep symbol represents MongoDB. Okay, it is not MongoDB, it is MongoDB, and expressive and strong consistency and data integrity. These are the properties of databases, right? ACID property. In any database, you will have atomicity, consistency, integrity, and dependency. So that ACID property here. Next, enterprise management and security. Data model flexibility. Data model can be changed at any time. Since it has no structure, defined structure, it has so flexible. Scalability and performance is also good, and it is always on. The MongoDB database can be switched on at any time, and the data can be retrieved anytime, suitable for global deployments. So that's why MongoDB is chosen as the blockchain database in most of the applications. Next, enterprise blockchain maturity model. So this shows how the today's model, this is actually today's model, right? So how it is evolved. So initially it was centralized, where bottom you have your file system. That file system will be, you have your database in the form of MongoDB or your any structured data or unstructured data in your HDFS. So HDFS means in big data, you have that MapReduce programming and all Hadoop distributed file system, right? So big data kind of thing. And next, processing layer, and on the top you have application layer. So where it is centralized, so it is stored in the central server. And next, the current scenario is partly centralized. See, you have file systems and you have some MongoDB applications and some database or blockchainified Mongo database. Okay, some are stored in normal traditional MongoDB database and some are blockchainified. That means it is distributed. And then it is processed and application layer will receive data. And now it is totally decentralized where you have some file system like your IPFS and your database is completely blockchainified. That means all the database will be in the form of blockchain only blockchain of blocks. Okay, and the processing, so it will be done normally by Ethereum and Hyperledger. So Ethereum, you know that smart contracts will be created. Okay, so Hyperledger will be used to establish contracts. So these concepts will be used and applications can perform their transactions or operations. So this is the evolution that we have in currently, right? Next, what are the platforms that you can use? So all these are, I'm saying regarding the programming point of view. Okay, so what are the common platforms? You can use, see there are different scenarios and for these different situations you can use different platforms. You can use Ethereum when you have public and permission based blockchain and your consensus. Consensus is actually required, right? So consensus means all parties in the system should agree to something, right? Okay, we can include this node, we can remove this node, we can include this contact block. So likewise we should agree upon something, right? So that is called as consensus. And there are different types of consensus and cryptocurrencies also there are different types. And if you are using public and permission based blockchain, consensus is POS, cryptocurrency is in the form of Ether, and if you have smart contracts you can go for Ethereum platform. Okay, or if you have permission based and your consensus is this crypto, if you don't have cryptocurrency and you have smart contract, you can go for Hyperledger Fabric. So similarly, multi-chain can be used when you have multi-currency involved, and Litecoin can be used if you have public script, Litecoin's cryptocurrency, and there is no smart contract involved, you can go for Litecoin. Okay, and next you have Lisk. There are different platforms, these are the common platforms. You have some more platforms also, and depending on your problem type you can choose the corresponding platform. Next, Quorum, when you are having permission based blockchain with multiple consensus and ETH and smart contract. HDAC, so these cases you can just have a look. Okay, and when you are developing your application you can refer this and choose your platform, right platform. And this is actually a table which is taken from a journal paper which was published. So where there are different types of blockchain nodes are shown and it is implemented on Raspberry Pi. So here this blockchain is integrated with IoT device, Raspberry Pi device, and we have synchronized the devices. Okay, and the blockchain node evaluation, so how much average energy, percentage CPU time, different parameters are evaluated when BIoT application is implemented. Okay, next average total MB sent, total received megabytes. Okay, so likewise for different nodes, Bitcoin light node, and again there will be something called as light node, full node, right? And for every platform the types of nodes may be changing. Bitcoin light node, Litecoin light node, Ethereum, Bitcoin full node, Litecoin full node. Okay, so S stands for during the process of synchronizing and AS stands for after synchronizing. Okay, so during synchronizing more time and energy is taken, and after synchronization, so the time everything will be reduced. Okay, so similarly for all the cases this is given. Based on your resource availability you can choose the right node, type of node for your problem. Okay. And next, these are different platforms to support BIoT applications. And actually this is taken from again a journal paper where this shows the different applications for energy microgrid. Most of the applications use Ethereum platform, and some may be using multi-platforms. Okay, combination of platforms. In energy for solving, so this you can refer to choose. Okay, I am going to work on this application, insurance network for IoT assets, means this may be suitable. For example, I am going to work on data integrity for supply chain, means this may be suitable. This kind of inference can be referred from here. Energy microgrid or power microgrid, you can go for LO3 energy. And there are different applications, okay, which I think you will not understand if I say now, but if you are actually implementing, you can just have a look. And this is actually a case study where ocean shipping blockchain consortium has been developed. In real world nowadays, this consortium has been formed. That means consortium means a group or an agency kind of thing has been formed for transmitting data or shipping data through oceans. Okay, for example, if we need cars to be imported from US, how it will be imported? Normally, it will be imported through ships, right? So through ships, it has to cross different oceans. But whenever they are passing different, they may be passing different countries, ports of different countries. There will be some policies, right? And when when the product is delivered to the supplier, many people will be customs officers. See. So many people will be involved in this blockchain process actually, right? So first port authority, see who is involved. Okay, so first inland carrier, who is carrying. Next port authority, there will be some people, authority people in your port. Next there will be some mechanism to carry this in oceans. Next you have customs office people. Next shipper. Next bank people will be involved. Insurance people will be involved. And freight forwarder may be involved. So there are so many peoples, and the data has to be transferred through all these people, and the required amount should also be transferred through all the things. For example, if a product is damaged at this side, again this has to be go back through all the process in reverse. Okay, how it is happening? So under participation of major parties, so ocean shipping industry actually has been formed, and it suggests the process using blockchain. Okay, so it provides end-to-end visibility, transparency, process automation, and security or scalability. So all these properties are achieved using blockchain consortium. Okay, so that means using blockchain technology for this ocean shipping, it is working good. So initially 15 participants have formed this, but nowadays 35 members have joined this. See, big companies, big organizations involved in ocean shipping. So Samsung, this HMM, even I don't know the different things, but see Amazon Web Services, there are 35 members who have enrolled in consortium, this ocean shipping consortium itself. So see logistics, Newport, there are so many people involved, right? So different organizations will be performing these different operations. So all have agreed to use this blockchain concept. That means transfer amount through cryptocurrency format. See, actually ocean shipping is a complex process. They themselves have moved towards blockchain. So it's highly anticipated that almost all our future applications will be moving to these concepts. And the common programming languages that are used are, see, so Solidity, I have already told you, no, Solidity is used by these applications, companies, and then C#, C++ are also used. 6 million plus users are using C++, sorry, C#, and this, and so this represents the number of people who are using this particular language. Okay, 8.5 million people are using SQL developer. So next 1.5 to 2 million people are using Ruby. Actually Ruby on Rails, no? So this is another language. Ruby is used. Java or JavaScript is used by 9 million people. So actually Java and JavaScript are used by many people. Next, Python is also commonly used. Nowadays people are using Go language. Okay, so Go language is actually created by Google. And now today's session we are going to see how to create blockchain program using Python. Since Python is very easy to implement, and that's why we are going to see Python nowadays. Okay, these are the languages that we have seen. Okay, in total, blockchain will revolutionize the entire IoT structure and speed up the interaction and integration between citizens, governments, and companies involved. And for this, consensus will play a key role, right? So it will be used to mine data, and in future, definitely, like our current money, so we are having cash money, no, in paper we are having the money. We are commonly using this money as currency now. So in future, definitely cryptocurrency will replace its place. Okay, so this is the basic idea about the theoretical concepts and how programming languages or tools are used in blockchain applications. Now we will see how to create programs. Okay. For creating blockchain program, you can use Python in Colab, any online compiler, or you can use in your Python shell or any Python environment. Okay, actually I have installed Anaconda, and on that I am going to work on Jupyter notebook. You can also try this, or even you can type the same program in your colab.research.google.com also. It will work fine. Okay, because both these things contain the important libraries already built in. So most of the standard libraries are already installed in this website, and you can avoid the workload of including all those things manually. Okay. So I will share my entire screen now, and I will show how this can be done. Is my screen visible now? Is the Jupyter screen, so the spider screen visible now, ma'am? Everybody? Can anybody say the screen is visible?
Yes, ma'am.
Yes, is it visible?
Yes, ma'am.
Ma'am.
Okay, okay. So I have already installed Anaconda. So from this Anaconda, you can type your Python program. I hope you all know the basic concepts of Python, and with that assumption, I am showing how to open Spider. So I have opened Spider, and this page will be open. So if I type Anaconda in my start, this page will be opened. Okay, so this page will be opened, and I am using Spider environment. So just click this launch. We have already clicked this. So when you click launch on the Spider, the screen will be opening. So where you can type a program. This left side you have the editor page where the statements, Python statements can be written, and on the right side you have the console window where the outputs can be seen. Right? So this is one way you can do your program, or you can go to net. If you want to use Colab, just go to Google and type colab.research.google.com. This will go to the page. You can type your program in any place. Sorry, the tutorial was open. If you have any doubt in it is opening some other language, I think the language was wrongly chosen. I don't know, somehow the language was changed. Okay, so when you open this collab research website, this will be the first screen, and where you have to click this new notebook. Okay, so at the bottom you have this new notebook which opens a new Jupyter notebook page. So when you open this page, so this kind of screen will be opened, right? So where here you can type your commands, right? So for example, I'm just printing, I'll just run you a simple Python program. I'm just printing hello. Okay, so just print your Python statements and click this run button. You can see the output below. Since it's working on the server, it will take some time. Okay, so on the below you can see the output. And for executing the next command, if you want to include a new code or command, you can just press this code and again we can type our next command. Here you can have multi commands also. If you have 5 to 10 statements also, you can give one by one, right? So print of hi, next statement, print of. Likewise, you can execute sequence of statements. Below the commands, you can see the output, right? Okay. So now I'll show you the program. Is it visible right now, ma'am? So if it is not visible or something is not clear, please let me know. Okay, so first I'm showing how to create a hash value. That means whenever some message is given in blockchain, a hash value will be created. So first for this, import hashlib. Hashlib is the module which contains the functions for creating this hash function. Okay, and blockchain initially is an empty. So in Python you have a list, right? So list means within square bracket you can create like this. If this is nothing but a list is created, a Python list is created. Blockchain equal to empty bracket. And now this function creates a hash value. I'll show you how. Okay, so I'll just execute this in okay, and after clicking this, after typing your command, you can run this. So when you run this, see the output here. The output can be seen like this. A new hash value is being created, right? See, 611 something, so which contains the combination of alphabets and numbers. So how this is created? See, blockchain equal to, you have created blockchain, but now actually we have not used blockchain. So you can just comment. Okay. So hash lib, in this module hash lib, you have something called as SHA, secured hash algorithm 256. This is an inbuilt already known standard algorithm for creating hash value. Okay. So we are just calling this function. SHA 256 function is defined in hashlib library. So hashlib dot SHA 256 of. Now I'm going to create secret message. See, this is the message that I have. Now this message has to be encrypted. In the sense, the hash value of this message will be created. Dot encode. If you give dot encode, encode means converting this into some code, right? So the secret message code will be this. Dot hex digest means in hexadecimal digest value it will be created. Okay, these are all the cryptographic terminologies. So just use this function. The message to be transferred within double quotation dot encode. Okay, this SHA function will create the hash value and this hexadecimal format will be created. So only then you see you have the values from 0 to 9 and A to F. That means it will be in hexadecimal format. So this is the hash value. It is stored in this variable hash. You can use any variable and you have printer. Now just if I'm saying, if I'm making some change, see I am just made a change. Now if you run, this hash value will be changed. See, now the hash value is changed. So how this change is done? So for every message or for every change that we are doing in our input, the hash value is changed and this change is reflected in the blocks of your entire blockchain. For example, if you have 5 blocks in your blockchain, if you are making a change in first block, the change will be reflected in all the blocks because all the blocks are connected together as chains. That's why, so for the second block, the previous hash value will be used. That means, for example, if you have, I'll show you with okay, for example, if I have a block, okay, if I have a block 1 already and now I am creating block 2, these two blocks are connected. Imagine this is connected to another block 3, okay. Now for this block, we will create a hash value, okay. So this hash value is created using the hash function, SHA function, and now I am adding new block. So initially it contains only this block and now I am adding this second block, means for this second block again hash value has to be generated, right? But this hash value will not be generated independently, rather it will use the previous hash value also. It will combine the previous hash value with its current value and generate a new one. And this third block will also create hash value based on the second block. So what happens if you change a message here? For example, if you just change, instead of message into massage, you are changing E to A. In your first block, automatically its hash value change. It also changes the hash value of second and third and all the blocks in your entire blockchain. This is how whenever a person or whenever a node has some value change, it will be notified to all the blocks in your entire network. And that's why security is ensured. Nobody can change the data without others' knowledge. When you make any change, it is totally notified to all others in the network. Okay, there is no mechanism of escaping. Okay, see, and if I am having another message, for example, I am creating another message. Okay, so this hash value will be different. So I am having this as just secret and storing this in hash 1 and hash 1. Now if you print, the hash values of two things will be different. Now I have not created blockchain. I have just shown you how the hash value is created for a message. Okay, see, the message will be created. So for the first statement shows hash for secret message and the second value for the second message. Okay, Yes, I hope it's clear. It's a very basic of blockchain programming. And next, okay, now we'll see how to create blocks. For creating blocks, we need to use the concept of classes and objects. Okay, in Python, we have the class and object concept, no? So we will be using this. First, I will explain this concept here and I will just run the program. First, import the hash library, because for every message, you have to encrypt, right? For encrypting, this SHA-256 function has to be called, and for this library should be imported. Next, class block. Create a class called block, colon, and every block should have the init method, right? This init method is like a constructor which constructs a block, okay, which is automatically called whenever an object for this class block is created. And here you have def init, okay, self previous hash transaction. So I will show you how this is executed. And the next, blockchain is created an empty list, and one by one we will add blocks into this list, okay. And you know what is Genesis block? What is Genesis block? Anybody?
The first block.
I think in Ethereum or something you have already heard about this Genesis block. Okay, the first block that we are creating in our blockchain. Very good. So here also we will be creating first the Genesis block, okay, equal to block of first message, right? So A sent 1 Bitcoin to B and B sent 5 Bitcoin to C. Actually, this will not be the original format, just if we have a message like this, how it is processed, okay. See how Genesis block equal to block main. So what happens here, we are creating an object for this class block. So the object name is Genesis block. You can create any name, but the common standard name that we give for the first block is Genesis block, right? So we have given the same name, equal to block of, we have two arguments, right? So the argument for any Python function is self. So after this, previous hash, right? So whenever we are creating a block, hash value of the previous block should also be included. So previous hash, this is the previous hash, okay. So first message check, you are sending some message, okay. And transaction will be the set of transactions that you are creating now, and you all remember that each block will contain n number of transactions, right? For example, some block may contain 5 transactions, some may contain 500 transactions. So every block will contain some set of transactions, and now my transaction contains this list. So that is why it is given as a list argument, okay. Within this list, A sent 1 Bitcoin to B. For example, I am transporting from Flipkart, okay, Flipkart to professional courier to my position, okay. So Flipkart sent 5 Bitcoins to professional courier, and professional courier sent 5 Bitcoins or 2 Bitcoins to me. Likewise, there will be some process involved in the transactions, right? Take supply chain management, logistics example. This will be clearly understood, okay. If this is the case, we are passing this as an argument, and now inside this what happens, self.transactions equal to transactions. For every block, these are the important properties. First, it will have the transactions, next previous hash value, and we are converting this string to hash, okay. So we'll see how. First message, what is in transaction, this A sent 1 Bitcoin and this, so this will be stored in transactions, fine. So what is stored in previous hash, A sent 1 Bitcoin to B, this is in previous hash, and this is stored in the member variable of the object Genesis block. Now this has to be converted, right? So this join transaction, this transaction plus previous hash, both will be joined. You know the purpose of join operator in Python, right? So it will be combined with and it is converted into hash, okay. So just a message is created, a variable is created, and now this variable is passed to this SHA function, so that a block is created. That means a hash value is created for this, and it is stored in the variable self.blockhash. So this is a local variable which is just used to concatenate the previous hash value with the current hash value. That means current transaction value. Okay, so every block will have these three important variables: transactions, previous hash value, and the current block hash value. Okay, so this is the program that we have seen earlier. So now this block is created, and again I am creating second block. You can do this also, but I am showing how to create a second block. Second block equal to block of, see, instead of this I am passing the previous hash. So what is the previous hash? Genesis block dot block hash. So it is stored in this object's block hash. So I am passing this. That means the first argument of this object is block hash value of the previous Genesis block. Okay, and my transaction is C send 7 Bitcoin to A. Now this is passed. Okay, so what happens? This will be passed and the second block will be created. And now you can print. So I am executing this program. See what happens. See, at the right side you can see. So block hash. So first time block hash, Genesis block dot block hash. See, now this value is generated and this second block hash value is generated based on this previous hash. Okay, this second block has its own information. It also combine its hash value, its transaction value with previous hash value and changes. For example, if you change the first Genesis block, for example, I am changing first message. If I am changing the first one, obviously the second one will also change. Note the difference. See, since the hash value of the Genesis block is changed, the second block hash value has also changed. Okay, now if you don't make change, the value will be same only. Okay, even you run the same program for 100 times, its value will be same. Okay, but if you change, instead of this M, I am saying K, now the hash value of both blocks will be changed. This is how chain of blocks are interacting with each other. Okay, I hope now it's clear, everybody, how to create blocks and blockchain. In this case, we have created two blocks. Yes? Anybody, is it clear?
Yes, ma'am.
Okay, so I just saw two more programs and close here. And if you are using Bitcoin, okay, so this is how blocks can be created, and there are many concepts involved in transferring cryptocurrencies and all that will be very difficult if you start here. So just know the basic of how to run the basic blockchain program, okay. And if you are using Bitcoin, if you are running in Colab, you can just see this. Bitcoin is actually not already installed in Colab, so you can first install this Bitcoin. See this module. Whenever a module is not already in Bitcoin, you can just install it by using !pip install that module name or package name. Okay, so now I have included Bitcoin, and this Bitcoin will be used to create keys, public key and that keys. Okay, see here. I hope this size is visible. From Bitcoin import star. Okay, so all the functions from this Bitcoin will be imported. Next, if you have some private key, public key concept, okay, that means if you want to explicitly include some mechanism for encryption by generating your key, you can do this. This can be done using this. After importing, you have random underscore key function, so which creates random key, so which is available in your Bitcoin. Okay, so random underscore key will generate some key. And next, if you want to convert this private key into public key, you have another function, private to public of private. Okay, so random key will be by default private. So if you want to convert this, you can convert this, and again this can be converted to address. Okay, see, this kind of address can also be generated, because in Bitcoin, do you remember, you have to create an address whenever you are using a blockchain, and for every transaction there will be an address associated, right? So this is how you have to create address. If you want to see address, you can see using Bitcoin. You can go in any Bitcoin address. That means already some transactions are happening. So for any transaction, you can go to this website. See, in blockchain, this is an address. The second link, I think you can see address. This is unique for any transaction in your blockchain. Okay, so choose your Bitcoin, so this thing, so wallet, or you can see here. So these are the unique address assigned to every transaction in your blockchain process. Okay, so this address should be created using this format. You have to create some random keys, make some conversions which are required for that, and that address can be used to uniquely record or retrieve your particular transaction. Okay, and next, these are simple examples. You can create multi-signs. Okay, so normally the digital signatures will be created. You will creating the hash values, no? So for this you have some message like this, right? So these are the hash values. Actually this will be like your fingerprint. If we have fingerprint all over the world, it will be unique, right? Similarly, this will be totally unique. Okay, this will be like your fingerprint. Imagine it's as a fingerprint. And if you want to digitally sign, actually this is all under digital signatures kind of thing, right? And if you want to sign using different keys, you can do this. See, you can generate multiple keys, and all these keys can be used to create a digital signature. See, first we are creating a random key, convert that into public and storing it in pub1, pub2, pub3. We have created 3 random keys and mk underscore multi-sign script. Okay, so this multi-sign, that means combination of multiple signatures. If you have many security threads, you can create multi-signature scripts. Okay, that means even if somebody hacks, it will be very difficult to track your message. Okay, so pub1, pub2, pub3. So you are passing arguments. A script address will be created and that is being printed here. Okay. So this is a very basic program. And next I will show you just one more program which creates a set of blocks and also transactions in it. Okay. So in this program, we have the definition of hash. Okay, hash function we have defined separately. In this we have called this SHA function. But here we have used JSON object. Normally, most of the blockchain applications will be using JavaScript and JSON objects. Okay, even Python program use JSON is actually a format for storing, right? Object notation. And it's not a special, it's not a separate programming language. It is just a representation of object, right? In Python also we use JSON object format. So this diff hash function. Next, we have created a blockchain set of transactions and this will be the output. See, first I will run this and show you how the output will be. I think there is some indentation error. Sorry, I have to copy from here. First I will explain the program and then you can easily understand. Okay. first hash lib JSON is imported, and every blockchain actually has timestamp associated with it. That means when that block is introduced. Okay, so the blockchain object has to be first created. That means a class called blockchain is created, and in that it has two member variables, chain and pending transactions. Both are list. It is empty initially, and we have self dot new block. Okay, so whenever a new block is added into this blockchain, this will be executed, and this new block is another function. Okay, so see, each block will have index, timestamp, transactions, proof, proof of concept, no, that proof, and previous hash, proof of work you have in Bitcoin, I think, So this def new block, pending transactions, property, these are different functions which you have already, and whenever a new transaction is done, this will be called. Okay, and this is hash function. Okay, we'll start from the first. Blockchain equal to blockchain. So we are creating an object for this blockchain class, and what happens, this constructor of this blockchain will be called, right? So in this constructor we have the chain. Initially the blockchain will be empty, pending transactions will be empty, and now it's calling another function, new block. Okay, so in this new block, so when we come here, the control comes here, this function is called, right? So for this previous hash equal to, we have given some hash message and proof equal to 100, and the previous hash none. So this is passed as argument here, and now a new block is created, and length of self dot chain plus 1. This chain is initially empty, so 0 plus 1. Now index value is 1, right? Initially it is 0. Now you have added one block, so the length of your blockchain is 1. This is set as index. Timestamp means the current time. The current time will be taken from this time function. For this you have to import this module. Okay, from time import module, this will import this, and you can use this function. And transactions, self dot pending transactions, actually pending transaction is initially 0, and proof 100, and previous okay. Okay, the previous hash value, see how this previous hash value is calculated. Either you can use the previous hash value, or if you don't have, the self hash value dot minus 1. Okay, that means self dot chain minus 1 will be created, and here we are calling a hash function. Okay, in this place the control goes to hash function, and it will create a hash value. Okay, using this JSON format. So that is why import JSON is given. So here this JSON object format is given. So now the hash value is being created for the current block, and this block is being created. Okay, so just with this simple statement, blockchain, its init method will be called, and from this init method, new block function will be called, and from this function, hash function is called, and now the first block is being created. Okay, and now we are initiating transaction. In this first block, we are going to add, see this block, this is first block, and in this we are adding 3 transactions, blockchain dot new transaction. This actually, this should be the format, Satoshi Mike. That means Satoshi sent 5 bitcoins to Mike. This is the format, and similarly this also. Okay, and now new transaction. See what is the function, self sender recipient amount. So the arguments passed will be set like this. It's a dictionary, right? So equal to transaction is a dictionary given here, and already pending transactions has 0. Now you append this transaction, and last block is another function. Okay, I think last block is another function in your program, so which returns the okay, see this last block is another function, it's a property. Okay, so it will return the last block index plus 1. Now if you add a transaction, that last block index will be incremented by 1. Now after this, a second transaction is included into the same blockchain. Okay, and now again this transaction function will be called, and it is inserted, and third time. So now these 3 transactions are added into the object blockchain, and we are creating new block, blockchain dot new block. So now this new block will be again created, and this contains all the transactions, and now this will be created. Okay. Similarly, next we are adding 3 more transactions to the same blockchain. Okay, next for this set of transactions we are creating another block. Okay, and now we are printing blockchain dot chain. See, this program will give you the output. So this is the output that you can see. Since it is clumsy here, I have shown the output in this program at the bottom. See, the Genesis block will contain all these things. We have inserted, first created a new block, right? After that, we have included 3 transactions and then 3 transactions. So first time index equal to 1 and the timestamp transaction is empty, initially with no transaction, and the previous hash value is this. Okay, so now after that what happens, we have added these 3 transactions into the blockchain, and now we are creating this new block. So now index value is 2, timestamp, transactions will now contain sender, Satoshi. So all those 3 transactions, details of this will be contained here. See, it will be displayed in the dictionary format. And after this, again we have created 3 transactions and included that as a new block. So index equal to 3, now you have this. Okay, so for everything you have this previous hash value and all those things. Okay, this is how a blockchain can be created with set of blocks and the timestamps, transactions involved. This is a simple example, and you have many examples also which you can go for advanced programming. Any doubt on this? Any doubt on this program? I think this, at least this program will give you basic intro about how to write a simple basic blockchain program. You have to first import the libraries, create a class for blockchain, create a function for new block, init method, and new transactions, function for hash, and create your, just within 50 lines you can create a blockchain program using Python. Any doubt in this? If you don't have any doubt, shall we close, madam? Some online resources. Okay, madam, I actually got details from many things. Okay, I'll just open the link, ma'am.
Yeah, ma'am.
I'll just share the link in chat box.
Okay, ma'am. Participants, if you have any queries, kindly post it in chat box.
These are some of the good links that I have referred. You can also have a look at this. There are many links, but these are good tutorials. And one more thing, this one, the last link that I have sent is by Ivan Ontek. Actually, there is he is a person, he is a technical person, but he has good explanation of the blockchain concepts. Academy.ivanontek. Okay. You can register for blockchain courses if you can, or at least if you visit the last link that I have provided, you can have a good intro. Lata ma'am, can we close the session?
Uh, okay, ma'am. Participants, if you have any query, please put it in the chat box.
Any queries?
Ma'am, I think there are no queries, I think so.
Okay.
Pony, ma'am, please conclude.
Thank you, ma'am. Your most valuable speech on blockchain, along with IoT, blockchain working principle, and integrating blockchain with database, blockchain, and implementation of blockchain would be effective for every participant and the research scholar here. We are sure that all participants would attain knowledge on BIOT. Once again, we thank you, ma'am, for your valuable inputs. We are eagerly looking forward for more such interaction in years to come. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
I thank Lada Jodi ma'am for giving me this wonderful opportunity.
Thank you, ma'am. Thank you so much. Thank you for your valuable session.
Thank you all participants, and thank you all the faculty members of Vellalar College.
So much, ma'am.
Thank you, ma'am.
We'll all wind up now. We'll meet 1:30 p.m. sharp for the afternoon session. Thank you.